Hey guys, welcome back to part 2 of the custom ships tutorial. Sorry this video is so late. The line for milk at the store was very long. In this video, we're going to take all the components we built last time, add some UI for wiring them up, and make them controllable. We're going to do this by adding delegates to the ship, or in this case Unity actions, corresponding to each of the player's inputs: throttle, horizontal, vertical, and fire. We can then link functions from our components to these actions so that they'll be called whenever the user presses one of these inputs. Note that each of the actions takes a float value as an argument, even the fire action, which technically should just be a bool. This just makes some of the coding easier. We'll set up some quick activate and deactivate code, which will unlink or link the ship from its construction table and activate it when we're done building. Last thing we're going to do in this script is call each of the actions, passing in the relevant input. If you haven't worked with Unity actions before, you can add pretty much any number of functions to an action as long as it matches arguments, and it will call all of them when invoked. We want a general ship component class for each of the ship's components to inherit from. While some of our logic is shared, there will be a lot of differences in the way the wheel, engine, and gun components will act. We'll add variables for the component name, its inverted state, and a list of this component's available actions, as well as a reference to the ship. Here's an example of how to create the engine component to allow the tilt and thrust of the engine to be controlled. First, we're going to inherit from the base ship component class. We'll add a reference to the engine mesh to be rotated, a thrust vector, and a max angle for the engine to twist. In the activate function, we'll initialize our local rotation. Then, we'll make two commands to connect to the throttle and steering functions on the ship. Finally, in the fixed update function, we'll check if the ship has been launched. Then, we'll write some logic to rotate the engine and apply a force to the parent rigid body. We'll add our throttle and control actions to the list of actions on the component so that the program knows which ones we can connect later. I did the same for the wheel, gun, and gyro components, but you could make any component you want, so I'll just scroll through them quickly. Now that that's done, we'll just add these scripts to the component game objects and set them up the way I have here. We also want to make sure that we've added a rigid body and a follow camera to the ship so that we can switch to a third-person view. I'm just using a simple parented camera, but you can also grab something cool from Cinemachine. Since I'm now using a rigid body on a ship, it seems to redirect the raycasts to the parent object, so add this fix. Before we launch the ship, we want to activate all connected components to give them a chance to initialize. Now it's time to start building up the UI so that we can wire this up together. We'll create a button to hold and display a ship component and its action, like Wheel 1 Steer, and we'll just add a plus sign at the end to tell us whether this component is inverted. I found this is useful because sometimes when you add the engines on opposite sides of the vehicle, they tilt the wrong way. We'll make that a prefab and create a new script for it. First, we'll implement some drag and drop functionality. If you get stuck here, check out this CodeMonkey tutorial in the description. When the user drags the object, we'll deparent it from its root and have it move with the mouse. We'll handle the drop stuff in a second. Now we'll just throw together a series of scroll views to put up a list of unwired components, and also a set of input boxes that we can drag the buttons we just made into. This will allow us to assign the component to the input. I make pretty heavy use of vertical layout groups, and this makes sure that everything stacks automatically in the canvas. Now we'll take care of the drop action. When we drop a button into an input box, we'll set the parent. We also need to know which ship input we're assigning to, so we'll create an enum type for each input and assign it in the inspector. When the button is dropped, we'll make the connection to the relevant input using the += command. Don't worry if this doesn't work quite yet, we'll assign the bound action soon. Now all we have to do is generate a button for each component action when a component is mounted. I'm using a singleton here, which I guess I didn't really need. Anyways, the add component function creates a button and assigns its component name, and action, and adds it to a list of existing buttons so we can destroy it if the connected component is removed. We'll do that in the remove component function. I use a little trick here to handle the change in list size when we destroy a component. The index I is only incremented when an object isn't destroyed so that everything stays in order. Okay, so now just a little change to the mount script to call the functions we just made, and we should be good to test this out. Alright, looks like it's working. While we're here though, let's finish the invert functionality. Also, so we know which component is which, we'll bump the scale when the user mouses over a component button. We can wire our components, but if the user wants to unwire them too, we'll handle that. Okay, I think we're finally ready for launch. We'll add some quick functions to launch the ship and to return to the editing platform. We'll map those functions to our launch and return buttons that we'll create in a moment. And there we have it, a completely customizable ship creator. Thanks for watching, guys. Bye!